How big is the sun? It rises in the morning, giving light to the land below it. It sets in the evening, leaving the world in darkness. The sun. Due to its obvious importance, it has been studied and observed since ancient times. The sun is a star, not so different from the stars that can be seen in the night sky. Our own sun is far from the largest star in the universe and quite small compared to some of the star giants we can gauge. But it's still huge in the grand scale of all we know. Within it, you could fit 1.3 million Earths. Picture a grape as the Earth. Now picture a 4-foot beach ball, and that is the sun compared to the Earth. In the whole solar system, the sun makes up 99.9% of the entire mass. Welcome to Brainbender Solarium as we travel through space and explore the sun and the sheer size of this burning body at the center of our solar system. So, let's find out the size of the sun. The star at the middle of the solar system is the sun. It is an almost ideal hot plasma sphere, heated to incandescence in its core by nuclear fusion reactions and radiating energy predominantly as visible light and infrared radiation. It is the most important energy source for life on Earth. Based on its spectral class, the sun is a G-type main sequence star. Even so, it is informally and not completely properly referred to as a yellow dwarf, meaning its light is nearer to white than yellow. It was created from the gravitational collapse of matter within an area of a large molecular cloud around 4.6 billion years ago. In the center, much of this matter is collected, while the remainder condensed into an orbiting disk that became the solar system. The center mass became so intense that nuclear fusion in its core was finally initiated. It is assumed that through this process, almost all stars form. Ever since ancient times, the immense effect of the sun on Earth has been known. The sun has been viewed as a deity by some cultures. Earth's synodic rotation and its orbit around the sun form the basis of solar calendars, one of which is the Gregorian calendar, the actual prevalent calendar. So what would the size of the sun be? Its diameter is roughly 864,000 miles, 1.39 million kilometers, or 109 times that of the Earth. The mass of the sun is about 330,000 times that of the Earth, and it contributes to about 99.86% of the solar system's total mass. Hydrogen consists of nearly 3/4 of the sun's mass, about 73% hydrogen to be more specific. About 25% of the sun is helium and trace amounts of heavier elements such as neon, oxygen, carbon, and iron. The initial chemical composition of the sun was inherited from the interstellar medium it formed out of. Primarily, it would have comprised around 27.4% helium, 1.5% heavier components, and 71.1% hydrogen. In the first 20 minutes of the universe, the Big Bang nucleosynthesis would have produced hydrogen and much of the helium in the sun, and the heavier elements were produced by previous generations of stars before the sun was produced, and scattered into the interstellar medium during the final phases of stellar life and by incidents such as supernovae. Let's talk about the sun's circumference, radius, and diameter. So the sun is almost a complete sphere. Its equatorial diameter and polar diameter are just 6.2 miles apart, i.e. 10 kilometers. The mean radius of the sun is 696,000 kilometers, i.e. 432,450 miles, making its diameter about 864,938 miles. You could line up the face of the sun with 109 Earths, and the sun's diameter is about 2.7 million miles. It might be the greatest thing in this neighborhood, but in contrast to other stars, the sun is fairly small. The red giant, Betelgeuse, is about 700 times heavier than the sun and 14,000 times brighter. According to NASA, they have found stars that are 100 times greater in diameter as compared to the sun. These stars are massive. They also discovered much smaller stars, which are just 1/10 the size of our sun. Nonetheless, still much larger than our tiny planet. According to NASA solar researcher named C. Alex Young, it would take about 1 million Earths to fill it if the sun were hollow. The sun may be larger than previously believed. An engineer and researcher of solar eclipses named Xavier Joubier develops accurate models of solar and lunar eclipses to determine exactly where during the solar eclipse the moon's shadow will fall. But when he compared real images and historic observations with the models, then he discovered exact eclipse shapes only made sense if he scaled up the radius of the sun by a few hundred kilometers. Also, missions such as NASA's Solar Dynamics Observatory or SDO and inner planet measurements around the sun's face do not refine the radius of the star as precisely as desired. NASA researcher Ernie Rigg said that just putting a rule on these photos and finding out how high the sun is harder than you think. SDO does not even have enough accuracy to nail this down. Likewise, it turns out, according to a calculation based on those, it's not quite as reliable as we would like it to be with the Mercury and Venus transits. Wright also said that numerous papers have provided findings that vary by as much as 930 miles using a number of methods. If you are planning on skirting the edges of the next solar eclipse, that might be a problem. Yes, it doesn't really matter to most people and it won't change anything, said Joubier. But the closest you get to the eclipse path's edge, the more chance you're taking. The overall volume of the sun in terms of mass and volume is 1.4 times 1027 cubic meters. Approximately 1.3 million Earths could fit within the sun. The sun's mass is 1,989 times 1,030 kilograms, around 333,000 times the Earth's mass. The sun comprises 99.8% of the mass of the entire solar system, prompting astronomers Imke de Patter and Jack J. Lissauer, who are the authors of the Planetary Sciences textbook, to denote to the solar system as sun plus some debris. And if you've just thought, is it such a big deal? Let us find out something. The weight of the sun is not constant. The solar wind has carried atoms and thus mass away from the star over time. The sun lacks an average of 1.5 million tons of material per second to the solar wind, according to poor astronomers Phil Plait. Meanwhile, mass is converted into energy in the heart of the star. Every second, the star's powerhouse transforms more than 4 million tons of solar material into electricity, Plait said. In particular, Plait calculated that during its 4.5 billion year lifespan, the sun lost a total of 1,024 tons of material, or more than 100 times the mass of the Earth. While that sounds like a lot, it's just about 0.05% of the total mass of the star. By growing older, stars usually get larger. Scientists expect that the sun will begin to use up all the hydrogen at its core in around 5 billion years. The sun would swell into a red giant and spread out beyond the orbit of the inner planets, including the Earth. Helium from the sun will get hot enough to consume carbon, and carbon will combine to form oxygen with helium. In the center of the sun, these elements will accumulate. The sun would later lose its outer layers by creating a planetary nebula and leaving behind a dead center of mostly oxygen and carbon around the size of the Earth, a very dense and hot white dwarf star. No matter how you look at it, up or down, inside or out, the sun is simply astonishing. It will continue to grow and burn far past the lifespan of humanity, and one day, billions of years from now, swallow this tiny little Earth. It is the cause for life on Earth, and without it, our planet simply would not sustain life at all. But that is a story for another time, where we explore a planet where the sun goes dark. That does it for now. Be sure to subscribe and hit that thumbs up button, and go ahead and check out some of our other videos. Thanks for watching, and we'll see you soon.